a little look at some of the videos. Just going to summarize the key points and what we need to worry about. So, at its heart, we have sort of what we call it's a law of electrostatics, which is that basically opposite charges attract and like charges repel. Now that's true whether we are dealing within the atom itself, where we have the positive nucleus and we've got, say, an electron, a negative electron. There is a force of attraction between these two things, so these things are attracted, that's why they're bound together. Or it's true as if we have an entirely huge object, and we have an object, as you've seen, where an entire object has become positively charged and another object has become sort of negatively charged. There is a force of attraction between these objects that is pulling them together. But if we have two objects that are both positive, got one positive and another positive, well, they will repel and they push apart. So it's true at the atomic level, at the particle level, it's true as an overall thing. So the question is, how do we make overall objects charged? Well, it's about electrons. Okay, so objects can become charged due to the movement of electrons via friction. Okay, so this is always by electrons. So what's happened in this top case here is that means that some electrons, have moved from this when they were rubbed together. Some electrons moved from this thing to this other object, and that's what left one being negatively charged because they gained electrons, one being positively charged because they lost them. The protons, because they're the big massive things at the central nucleus, they do not move. So it's always about friction. Okay, now what this means, and as we've seen, is that we can use this. Like this is actually a useful thing because we can make things go where we want them to go. Okay, so what we can do is, this can be useful in making objects move towards each other or apart. So the example that they had was paint. Okay, so we have an object, so what was it? A bike frame, wasn't it? Okay, so we had, a frame that was being painted. So this is an example. So we've got that's not paint, that's just the object to be painted. And we fired at it from a gun. We fired sort of particles of paint. Now what would happen is as they move, as these particles come out, they are going to pass through a grid or something that's going to leave them positively charged. So what would happen is as these things become positively charged, that means that they spread out. They're going to spread out evenly because they don't like being near each other. And what we do is we charge this thing up so it's negative or neutral. It doesn't actually have to be either way. And what that will mean is that the paint will attract to all the different parts of this. So we get paint sort of evenly. So so by firing positively charged paint at a grounded or negative charge frame, the paint will form an even coating. And the advantage of this in industry is it takes less time, it is quicker, it takes us time quicker, they're the same point. It waste less because less paint falls on the floor. So the whole process, in efficiency terms, if you're not just painting one bike frame or you're painting cars, you're painting thousands of things, well, this is very quick and easy and is the best way to do it. So you might get lots of scenarios where you say, oh, here's here's something, how could this be used? And it's always a case where you'll have things that are oppositely charged, and it just means that things go in different ways. You'll see in the CGP, this is actually at the heart of photocopiers and inkjet printers. The CGP makes it sound really complicated because there's a few other things going on. But realistically, there are only two sort of ways. One is that you can charge, by having ink which is charged, you can deflect it to the way you want it to be on the page when you're printing. And in a photocopier, by having positively charged toner and a negatively charged sort of like plate, you can get things to go where you want them to go. So it's always about the attraction between positively charged things or negatively charged things, or the repulsion between them. So you might get given the scenarios, oh, how's static electricity used in this? It's like, well, one's positive, one's negative. They attract, or they're both the same charge, in which case they repel. So it's a fairly straightforward sort of thing. However, although it's useful, there are also dangers. Okay, so so static electricity. So as static charges build up, they can cause electric shocks. Or sparks. Now, we've all been shocked by something, and that's in the first video, it's because if you walk around and you're walking around on, say, a thick carpet which is insulated, you end up losing some electrons. So when you touch something else that's neutral, you get a rush of electrons. That's what you feel as the electric shock. But sparks are more dangerous, okay? Because if there's a source, if there's a fuel, something there, then what this can do is it can ignite this can cause an ignition of fuel. So sparks can cause, that's a terrible view. Let's rub that up. Can cause fuel to ignite. Okay. So the example that they had in the Brainiac video, where they had a little fuse wire going into a caravan, and we saw a spark that was here. You can think, how on earth did that spark? Well, that wire would have basically then been closely felled to another one which was going to the earth, and so there would have been a spark here that would have travelled down, and then there would have been a secondary spark here, and that's the spark that caused the caravan to blow up, which was dangerous. Now, so they had to do that. They sort of had a little fuse wire that could take the spark inside the caravan. You can see how quickly it was. Question there is, okay, how do I stop things sparking? Okay, how do we, because any time where there's things moving, where there's friction, things are going to get charged. Common examples of this could be if you're filling up, when you're filling up a gas station, and so, So because if you drive into a thing, so if you think about a car, so cars are sort of built up on in my car, as they drive around, they will, so as you drive around the car, well, these tires are rubber, so there's an insulation of this, and as you sort of buffeted by wind, well, what that's going to do is there's a high chance that you're going to, through friction, remove some electrons from the car's surface. So the wind sort of like gains these little electrons, leaving eventually a big positively charged car. And that's dangerous. That car could become dangerous. And the thing is, the bigger the object, the more dangerous it is. So there's a risk that when you try and then put your fuel in, you could get a spark between the hose and where the fuel's coming out, and you blow up your own car. Now, how do we stop this happening? Well, there's two ways. Stop it happening by earthing. Okay, so an earthing, and you'll see it. They don't tend to happen on the car, but they'll tend to be is actually in the petrol station itself. You'll have the you'll have the sort of the nozzle. There'll be something in the petrol station. I'm just going to draw it. There's our petrol pump, and there's the nozzle that you're going to take out. And you're going to put it. So if you just take the nozzle and put it into the car, if the car is positive, I'm going to move it slightly closer. Let's undo that. So we've driven in. Our car is positive, and we have a positively charged car. The risk that we've got is if we connect our fuel source to our car and then start in, there is a risk of a spark happening between the car and the nozzle, which means that as the fuel comes through, you might get an ignition and you get an explosion. However, what we do is we tend not to have that happening. Now, the way we have that is that this is going to be earthed, and there's going to be lots of metal connectors, which mean that before the instant you touch the instant that this thing makes a connection, there is a direct, and before you can pull the trigger and start throwing the fuel in, there will be a connection here, which means that there's a positive charge here, so we need to get some electrons onto the car. There's extra electrons in the earth. They will run up the side, they'll run around, and they'll run into the car to neutralize any charge. Rapidly, happens exceptionally quickly, far faster than it is before you can actually have the sort of the nozzle deliver any fuel within your car. So the static charge is neutralized before anything goes down. Now with a car, that's kind of simple because cars never really bring up a lot. If you're fueling something like a plane, well, the friction of the speed at which you're putting the fuel into the plane, because you want to fuel it really quickly, that itself would have a risk of sparking. So you have to earth the plane, you have to earth the fuel nozzle, so that if there's ever any buildup of charge anywhere, it gets instantly neutralized. Because basically, if there's ever any doubt, you earth things. And you might remember in electricity, there's an earth wire. Spare electricity can flow to earth really much more quickly. So you have a metal wire that connects to things to balance out any charges. If an object is positively charged, it will take electrons from the ground. If it becomes negatively charged, it will send electrons to the ground. So the build-up of charge can be prevented by earthing the object. This is done by connecting a metal wire between the object and the earth. And they can be very simple little wires. You can have them, if you're about to refuel a plane, you connect it to metal wires to it to prevent any charge buildup, and then you refuel it. And this is how we neutralize it. So electrons will either flow up or down the wire to neutralize the object. So it is. So it works in a very similar way to the earth wire inside an electrical appliance. But however, a couple of differences. One is that in an electrical device, you've got standard normal electricity. It's not a static charge that's built up. And in that case, that's always the case of something that's become live. So electricity will always flow down the earth wire to the earth. So there's always, in an electrical appliance, it's always one way. It's always to the earth. In just an earth wire that's connected to something, the electricity might flow, electrons might flow up they might flow down the wire, depending on where the positive charge is, which thing is either positive or negative. And that doesn't have to be connected to any kind of live electrical surface, because the object will have been charged simply by the movement of things through friction. But yeah, that is sort of like the examples we've got. I'll put an example in of static electricity being used. Exam question.